I'm presenting also something about cold bending, also related to a real project. I think it's quite important talking about reality, not only about artificial assumptions. And the topic here is looking for solutions for structural glazing, joint optimization in cold bend units. The project I'm talking about, it's called Mistral Towers. There are 2 towers in Izmir, Turkey, where we have one tower as a residential building, and the other, the bigger one, more blue one here, the office tower. And the target for the office tower was build-up of a building with cold bended glasses. You can see here some drawings for the building itself. Just a pointer. Oh yeah, here. It's a façade. This was the first draft of the façade. As you can see here, due to the shape they had in mind, or the architect had in mind, they want to use, or they had to use a lot of triangular glasses to realize the shape as wished. But due to some cost topics finally and realization topics at the second, it was not able to make it happen finally. Therefore, they decided to change the facade. They have done a parametrical study and optimization in order to bring everything to rectangular units. And with this rectangular units, of course, they had a quite nice cost-effective solution. But they end up in a second problem. Second problem was that the glasses now must be cold bended in order to realize the shape or the targeted shape of the building. Here, some figures for the project itself, or not for the project, here for just for a single unit. We talked about units with a dimension of around 1.5 by 4 meter, with a cold bending on one corner point as a max of 32 millimeters. We talked about insulating glass units with 2.5 kilopascal wind, mechanically supported in paint plane. Then temperatures which have to be considered as well, and then the adhesive used for bonding the glass panels to the frame afterwards. Here, the design they had in mind, they had a 185 millimeter depth frame, and then bonding a non-stepped insulating glass on top of it. But the problem they had, the problem they had, of course, finally the load case, the realistic load case which are acting on the silicone joint, because with the design they had, with the production idea they had, they end up in much too big dimensions for this material. For consideration of loads, of course, they have not only the cold bending itself, there are all the other loads which are acting on the joint as well. You have this wind load topics, you have the spring back topics, you have temperature effects, and therefore you had a lot of topics for tensile forces, as well as you have to cover the shear movements out of the application. Then, coming to the cold bending. For the cold bending, you see here just a scheme of the topic itself. For the tensile stress, of course, we had to consider the tensile stress out of the deformation, but in this case in 2 ways, because the one thing for consideration of the bending as a short-term force in regards of considering the glass as a very stiff, as a full composite, a stiff element as a full composite, or long-term force. That means that also in the glass you will realize certain creeping effects, especially on the PVB foil and so on, and therefore the load to bring the glass in place would be much lower than considered as a short-term one. Finally, of course, you have not only to measure the force, you also have to define the stresses, the design stresses, which can be considered for this special approach. The same thing, not only forces have to be considered, as well as the displacement, especially for cold bending, has to be considered as well, as at first the value could be quite high. And secondly, we are talking about a long-term situation, a long-term loading, which is much more critical than the short-term. Then we realized that for the materials itself, the stresses we can consider based on standards and so on we already have, they are not enough. Because considering the European standard, the IOTA ATAC, we have values for our products, we have design strength, we have design shear, permanent shear, we have the modulus, but what is missing is permanent tensile, but also a factor or a value, design value, which gives us more freedom for considering this cold bending in a better way. Because the permanent value we have here, I think it's a little bit related also to the presentation before, is the 1 psi or 0.01, something like this we are using in the standardization in Europe or in America, is avoid creeping. This is the target with this value. If you use this kind of strength, you will have almost no creeping anymore. But here we have we are enforcing the glass to bring it out of, bring in a certain deformation, and with this one we are creating a relaxation on the silicone joint as well. And the relaxation means that over time the stress will be reduced by a lot. Even we have a constant deformation, and the stress itself will be less, and due to some experimental analysis, we end up to see that this tau permanent could be easily 3 times higher than the values we are using normally for standard calculations. Then, you will see here now the approach of the real project. This was the initial design. Too many points on this. Here was the initial design. The idea was bond the element and then have this cold bending on site. Taking the approach I mentioned before, we would end up in a thickness, the required thickness of around 50 millimeters, and this is by far not feasible. This cannot be realized, and it's also not realistic, finally. Then we thought about the whole situation, and then we had to find a different way. First discussion with the facade builder itself, change the frame. With changing the frame, putting in an adapter frame, which allows a certain movement in all directions. With this one, the displacement itself was reduced by a lot, from 3-point-something millimeter to 0.2 millimeter. And now, with this adaptation, 6 millimeters in thickness of joint would be more than sufficient. Considering all other loads as well, we would end up with 25 by 8 millimeter. Reasonable joint dimension, but the problem was complete redesign of the project, also not feasible. Therefore, next idea. Next idea was pre-shaping of the frames. Pre-shaping of the frames, making this cold bending process in factory and install afterwards. Then you have the perfect solution because you have no displacement of a structural glazing joint anymore. Therefore, it must not be considered. Joint dimensions, 18 by 8, everything is easy and can be realized from this point of view very fast and good. But the problem, pre-shaping of elements, transport of the pre-shaped elements and so on, again, almost very difficult, almost impossible. But here in this project, we were in the very nice situation that the place of the project was quite nearby, or the factory was quite nearby the project, and therefore we found a different way with the customer in this regards. The production was done with a pre-shaped or cold bent frame, so therefore we had the chance that the material was cured in a stress-free, or not stress-free, but in regards of deformation or without any deformation, the sealant was able to cure. Then for the transportation, the glass was brought in the flat area again. Now, just for transportation, we had the topic of cold bending for the structural glazing joint. And then installation, the glass or the element, the whole element, would be brought in place again, means it was cold bended again. But now you can see here, also on the joint as well, without any deformation on the structural glazing joint, and therefore just with adapting the way of production into a different way, it was possible to exclude deformation out of the joint due to cold bending. Then, of course, not only the topic of cold bending must be considered, as well as other loads as well. We have this permanent loads acting on the joint, in this regards the cold bending. Then for service life, short-term loads have to be considered, a combination of cold bending, wind and thermal impact acting on the facade elements. And then for the transportation, a kind of a mid-term loading, not short-term, not long-term. In this regard, it was related to around 7 days. And here it's a cold bending effect plus some thermal loads. Taking into consideration all three cases, we end up with a joint dimension finally of 18 by 8, covering all the loading acting on the joint. Then, of course, there are other possibilities as well. You have seen now topics out of changing the design, changing the way of production, changing the way of installation. Of course, you can also combine topics like this. Combining means, in this example, changing the frame plus adaptation of the production process. Here, this is just as an additional example, a joint dimension of 21 by 7 millimeter would be even sufficient. Here, overview about the results I mentioned before. Realized finally was this one, with a joint dimension 18 by 8, considering all the loads acting on the joint in the best way, by adaptation of production process. Finally, all these topics were we revalidated by a finite element calculation as well. With this one, a full study in volume elements was done using a hyperelastic model, and for the validation of values, I think the results look not much different to the one we have seen before. We have then, of course, with peak stresses acting directly on the corners on the joint, and with this one, you see here, with the stress level acting on the joint as well, and but just a punctual load, and a punctual overloading of the joint itself is not a big deal. And secondly, of course, for revalidation of the values, comparing with the design stress, the standard specimens we are using for this one, this called H specimen, they are not the best ones in this regards. So therefore, using values out of pure material data is much better. But finally, the finite element method calculation just reconfirmed that the calculation done before in a manual way was right, was okay, and then the project was realized afterwards. This slide I see the first time because this is not my presentation. Now, but coming to the conclusion, I think it's quite important that for cold banded projects, not only considering the adhesive itself, it's also very, very important to have a global picture onto this topic. And the global picture for me means starting with the design of the facade element itself, talking about the production process of the elements, glass plus frame. Third, the topic of bringing the right installation method in place. And then, of course, have a realistic view onto the topic of cold bending. That means cold bending is a good option to go further, go behind the standard topics we have so far. But on the other side, I think it's also necessary to be somehow realistic. Cold bending will not replace the hot bending process. So this might not be feasible. And here, as I mentioned, have a global picture onto the topic from design, manufacturing, and installation. Then with playing with the right framing, playing with the right design of frames, you can adapt and improve and optimize a lot. Then find the right way for use the right way of calculation for the adhesive. Not cover the standards because they are very limited in this regards. You have to go behind this one. Then the finite element method, of course, gives a chance for revalidation of all these topics. And then I think it is quite important, already presented before, have a deeper view into this relaxation phenomena from the structural joint materials in order to have a better understanding what happened with the material and where are the limits. So thank you very much for your attention. And now if you have questions, please.
Do we have any questions?
What was the design strength for the medium-term 7-day transportation load? Was it closer to a short-term strength or a long?
This was quite close to the short-term strength, yes. Because it was just this mid-term in this regards was just for 7 days. So it was, we had a clear view onto this topic and it was quite close to the short-term load, yes.
I think it's, for me, it's similar to environmental and climatic load durations.
Yeah.
Is that data available from SICA?
Yep.
Great, thank you.
Yeah.
I think it's quite interesting to see both approaches and to compare both approaches from down and SICA. Basically, both companies are saying that cold bending is a relaxation issue and you're allowing higher stresses. But then one is approaching over strains and the other one approaching over stresses. So I think it would be interesting to get a common understanding of these figures one day.
That's for sure, yes. It's right.
But I also like the idea of the adaptive frame. But what about the position at the edge?
For the edge, at the end of the day, there are possibilities to create a certain freedom inside the system. You have, with adaptive frame, you have not the unlimited freedom, that's for sure. So, because somehow you have to connect both frames with each other. And then, as you mentioned, on the corners, you will end up in problems, or could end up in problems. But the idea with an adaptive frame would not mainly to avoid any kind of displacement. It's more the topic of reducing of displacement in the structural joint.
We have another question there. Thank you. Just a second, you get a micro.
You talked a lot about 8 times 21 millimeter sealant, but
yep.
not so much about the sealant in the IGU. Did you calculate that and use the same warranty, or did you take over the warranty for the IGU?
No, for the IGU, it's the sealant manufacturer cannot take over the guarantee for an IG unit. So a sealant manufacturer can take over the guarantee for the sealant itself. But in this case, the sealant was, or the insulating glass secondary seal was calculated as well. But here we don't have topics of optimization because the glass itself, here we had the classic cold bending without possibilities of adjusting the production process, the design process or something like this. Therefore, the insulating glass was not part of this presentation now.
So is there anybody giving a warranty on the insulated glass in this building?
I think here we have to ask, we have to ask the insulating glass manufacturer for this one.
Bad answer.
So it's a
Okay, thank you very much, Ulli.
good, thank you.
Hi there, did you like what you just saw? If you did, why not like the video? Drop us a comment below as well as share the video with others, since GPD is all about sharing. And to receive more videos in future, subscribe and don't forget to click the bell icon for notifications. Ciao!